and meanwhile, I will turn on the presentation on my side.
It is recording now.
Okay, awesome. So hello again, everyone. I had a few issues with the Teams, but I believe that they will not block us to have this awesome session today. So as Stas already said, my name is Anton Boyko, and you probably know me already. So I will more or less skip my part of the introduction, but I would like to invite my colleague, technically my former colleague, but still my good friend Aris. Aris, can you please say a few words about yourself?
Thanks,
Aris?
Anton.
Yep.
Thank you, Anton. So hello, everybody. My name is Aris. First of all, thanks a lot, the community, for inviting me, and Anton for organizing this meetup. I am from Greece. I live in Netherlands, and I work 11 years as architect in information systems and security, cloud infrastructure, and application. I've also worked a lot in finance. Today, I'm principal architect in Capgemini, and I'm also involved a lot in technology innovation. So we have prepared a couple of slides today to go into some security aspects, some common, and maybe we can also address some more innovative if we have time. So yes, thanks again for inviting me here, and let's start.
Yep, and before we'll actually switch to the next slide, I would also like to highlight one thing. So the way how we actually crafted our presentation for this meetup, our main target audience, or at least we assume that that will be our main target audience, is the developers who wants to know a bit more how they can make their applications secure. So if you are a developer, if you want your application to be secure, but if you don't know exactly how and where you should start, you basically get the right session, because that's what we will talk about today. Okay, so let me start from the beginning. A long, long time ago in a galaxy far, far away. So what was actually a long time ago in a galaxy far, far away? There used to be a technical debt. So I will start from, like all the basic stuff. In terms of the technical debt, if you don't know what technical debt is, I do believe that this picture basically explains it perfectly. So what are the common causes of technical debts? Let's start with the first one. That can be the insufficient of upfront definition. So that actually usually happens when we make a lot of assumptions, when we don't define exactly what the scope of our work will be and stuff like that. That's basically one of the most common issues to start accumulating technical debt. The next one is the business pressure. So business, they always want, like from you to deliver all the new functionality, and usually they pressure you so hard that you may actually start thinking, okay, maybe I should cut some corners, maybe I should implement that feature first, and then like next sprint or next release, we will also handle the security, the performance, and other non-functional requirements. That's another way how you can accumulate all the technical debts. Another one is lack of process or lack of understanding. I used to work in one interesting project, and I call it interesting because that was probably kind of once in a lifetime experience. I'm talking about that in that project, we used to have a daily calls, and our client, he understand Agile to probably the most extreme way possible. So technically, we had our sprints in a way that the length of the sprint was 1 day, because that used to be a regular calls with our client. And for example, like 4 p.m. my time zone, the client was the US based company. 4 p.m. my time zone, I get to the call with the client, and we discuss something, and he presented new requirements and asked me and then the team to deliver that tomorrow. Tomorrow we showed him the demo, he sent us new requirements, and again that basically that project lasts for like 3 or 4 months, something like that, but the overall experience of having sprints in the length of 1 day was kind of once in a lifetime. Another one, that can be a tightly coupled component. So that's pretty much straightforward. If you have your components tightly coupled, and if you understand somewhere like, further your development cycle, that you need to start introducing some non-functional requirements like, again, security, performance, availability, and that can be extremely complicated. The lack of the documentation, of course, and last-minute specification changes. So the question is why I'm actually explaining all that stuff to you, and here is the reason. And the next slide, this slide, and again, I do believe that we will be able to share the PDF version of our slides with all the audience, but this slide is probably one of the most important slides for the whole presentation, because what I want to show you here, I want to show you the cost of an error. And the idea is that if you will basically address that error, let's say at the latest stages of your project, it will cost you much more to fix. And one of the examples, of course, it's not truly related to the security, but still, I do believe that this is the perfect example as the well-known story with Samsung Note 7. Based on different reports, the total cost of that error was around 17 billion US dollars for the Samsung company. So yeah, I mean, like the key point here is that if you can address something, and security is one of the things that you should also address at the earlier stages, like on a concept stage that I show you here, it will cost you much less to fix. And now the moment of an advertisement. So 3 books I would like to recommend to you guys. The Deadline, that's actually one of my favorite book, the Geekonomics, and also the Project Phoenix. Again, all the slides will be available after the presentation, and you will be able to check the exact titles of those books, because probably my small team's icon here kind of blocks part of the slide, but I don't believe that that will be a big issue. Nonetheless, let's start talking about DevOps. Okay, so we actually know more or less what DevOps mean. We usually have this cycle. We do have a design stage, we have a code stage, we have a build stage, deploy and monitor. And now let's say that we want to make a transition from a DevOps to DevSecOps. What it will actually mean? It will mean that now we will still continue actually doing all that stuff that we used to do before, but now we will invite a security expert to join our team, and we will address on each of those stages, we will also address the security requirements. So we will do the same DevOps routines, but now we will do them also securely. Okay, and let's start with the first stage. Let's start with the design. Okay, so let's say that you want to address your security requirements on a design phase of your project. So what you need to do here, the first and the most important is that you need to define what actually secure means for you, what it means for your project. For example, can this qualify as a security? I don't know. Is this a security you're talking about? I don't know. So usually, in most of the cases, you are somewhere in between. Yeah, because again, if we're talking about financial applications, and Aris can actually support me here as well, that when you're talking about financial applications, about banks and stuff, they do take all the security things seriously, and potentially you can be even unable to deploy a hotfix if it didn't pass like a security gateway or something like that, because it can actually fix one thing, but for example, introduce some huge vulnerability. But on the other hand, if you're working in, I don't know, let's say retail, or maybe like you're working on a marketing platform, then for those guys, they are actually more or less flexible, and for them, the requirements for the security may be a bit lower. But in any case, you cannot say that my project needs to be secure. That's not a definition. You need to specify exactly what security means for you, for your project. Okay, and talking about different security layers. Aris, do you want to take over this slide?
Absolutely, Anton. So I've prepared this this slide for you. It's slightly different than the slides that you will find on Google. So here I will take a few minutes to talk about security layers and get a more, I would say, year 2021 understanding of the actual security layers. So as you can see, there is this is like an onion. So this is a layered drawing. It's not an invitation to a trance music party, no, but it's showing the security layers from high-level logical point of view. So let's start from the external onion layer, and let's go inside to realize some modern aspects. So security, and first of all, it starts from the organization and the human entity. Why does it start there? So security, first of all, starts from a physical environment. Physical environment and physical entities inside this environment. For example, if I have a data center, so let's say Microsoft Azure data center, that is, it will be soon, as far as I know, it will be soon created, a new one in Ukraine. So if I have an accident inside this space and there is a fire, so that is also a security threat. And that specifically is a security incident. The specific one is a physical security incident. I will not elaborate more on the physical security aspects, but I brought this example so we understand better and visualize in our minds this layered high-level overview. Let me now explain you the areas, the security landscaping. So security starts from physical environment, and first of all, it's the entities, which is human or an organization, if it's a company or if it's a website or a social network. So so the users of that social network is the human layer. Attackers often target this layer because exactly of the low level of security awareness. For example, someone that his profession is not relevant to security and information technology in general. So that person is most possible not to have good security awareness. So if that person is using a platform like Facebook or LinkedIn, the security risk there and the risk to have an actual security vulnerability in this interaction is much higher versus when I have a team with cloud engineers, for example. And this is why attackers and malicious scripts often are programmed to target this layer. Now, moving inside, physical perimeter. I told you that security starts from the physical environment. Physical perimeter is any other physical factor or entity that contributes to security. I described the example before with a fire incident close or inside a data center. Of course, modern data centers have taken all the measures to prevent that, but let's assume that it could possibly happen. So physical perimeter is, for example, the automatic fire extinguisher you have in your data center, or maybe in your private small rack inside at your home, for example, where you are trying some Kubernetes experiments. So if you have a fire extinguisher which will start performing automatically with a smoke sensor, that is your security at physical perimeter layer. Now, network and infrastructure. I think everybody knows about this. I will not elaborate too much. So it's network is the connectivity between the instances. So we have a Restful API. Maybe we have another microservice or a data aggregator calling it, or maybe just a simple user, trying to log into LinkedIn, a casual login. So we have a physical entity trying to log into a service which is published through a graphical user interface, right? So network and infrastructure is all the components and resources and configurations that are protecting, first of all, at connection level. So when a physical entity or a digital entity tries to connect to some service, the network and infrastructure is the area where we can have our first security defense at the digital level, of course, after the physical environment. So firewalls, operating systems. Can a server be at infrastructure and network layer? Yes, it can. Now, I told you that this diagram is slightly different than the ones that you will find on Google. Why? Because I tried to deal with some 2021 aspects. So a service, which is a server, can be at infrastructure level. For example, can be an Apache server. All right, so you need to properly configure that to make it secure. But a service can also be at endpoints and services level. So here is how this slide differentiates from what you will find in Google. So what does it mean, endpoints and services, and why we can also find a server there? What is a RESTful API? A RESTful API in reality is an HTTP server. You can make your RESTful API with Node.js, with C#, with any programming language. So especially for example, Node.js example is visualizing that well. Node.js is amazing. When you do, but when you do a RESTful API with your Node.js, you must also take the security measures at code level, specifically your HTTP server code, so to secure it properly at that layer. And that said, I just explained the endpoints and services layer. So services and endpoints layer has to do with RESTful APIs, a web service that you created with your code, which may not be tightly coupled with the operating system and with the actual hardware machine that you are hosting it at. For example, you can have your RESTful API or your HTTP server or web server deployed in a Docker instance. Now, moving inside to application layer, I think that everybody knows this layer very well. The application layer is the logic, is your code. So is the security level, which is after the external physical environment, after the connectivity level, network infrastructure, and after the service level, which means that the data, the inbound, the incoming data have passed all the other security measures, and now they have already reached your backend logic. This is the application layer. Data security and it's leading inside at the data critical digital assets. Now, many people confuse the internal core of this diagram. So someone might ask me, why do we have a data security layer and inside we have data? So, for example, you can tell me that with your C# code, you have taken security measures and no unauthorized access can reach your database. But let's say that your backend service, for any reason, doesn't really matter what's the reason right now. Let's say that it got compromised and something malicious got in. So what is the data security before accessing the data? It's not the security. It's not necessarily the security configuration you will do at your Microsoft SQL server, because your Microsoft SQL server belongs to the infrastructure layer. So security at data level means, for example, encryption, anonymization, if it's PII data. It can be obfuscation, so it means encoding. So depending your needs at your data level, you will apply the appropriate strategy there. Just a short explanation on the bullet points I listed before. So encryption is the maximum level of data, if I can call it encoding. All right. So it's the maximum level of encoding security. Now, sometimes we might not need to use very complex cipher and algorithm to encrypt our data. So we might do something more casual because the value of that data is not that critical. However, all the measures that we take to anonymize and encode and encrypt our data, these exist at the data security layer. And what is inside? Inside is the actual treasure in this vault, and it's your data. And in a dev test environment, your data might be random data you generated with a data generator, can be other data that you aggregated or downloaded from a data set if you are a data engineer. But in a real situation, like Anton said before, in financial applications or other commercial applications, that doesn't really matter, because the risk sometimes, the risk is in analogy. So a bank, when it manages financial and private data of the civilians, so the risk there is very, very high, but also the investment in security is very high. In a smaller or a small medium enterprise that has just a simple e-shop, the risk and the damage in case of a security incident is in an analogy to a larger setup. So if a small medium e-shop has a cyber attack and goes down, that is still a small company. Maybe it has 10 employees, but that is still a company that is taking damage that time, and that damage in analogy is equally important for that smaller entity. So what is your data as critical digital asset? Your data is the most critical part of your system, of your application, of your startup, your innovation, your system. So the data is the most critical, valuable asset in your architecture. And in the case of finance or e-commerce, many times we can find the famous PII data, which are private consumers' data, like some identification number, some social security number, or credit card number. So exposing this data, having a security incident that leaks this data, can even lead to many innocent people losing money from their bank accounts. So that's it about the security layers, and I took a little more time on this, but I think it was important to realize in a little bit more depth the security layers. So that's it, Anton. And now we will talk about OWASP. Normally here we should have, oh, there is some animation. So OWASP is a non-profit foundation, exists many years now. I don't recall exactly when exactly it was founded, but it could be close, maybe a little less than 2 decades. Please correct me, someone, in the comments if I'm wrong here. But it's a lot of years here, and it's a non-profit foundation which is working to help in an open source manner to help organizations, startups, professionals, amateurs, doesn't really matter, whoever is involved in software development, and lately in infrastructure development as well, because now OWASP started the Docker top 10. I will elaborate in a few minutes. So OWASP contributes optimizing the security and is revising its strategies almost every year or every 2-year period. And they are working to define the best practices and provide for free to everyone as open source a well-established security foundation. So what does this mean? That means that it gives you for free guidelines that will help you to secure at basic or even at very advanced level, that is up to you, to secure your applications. If we can proceed a little bit with the animation of the slide, so we can have all the records, and I will start saying a few lines for each. So the most famous OWASP project is the OWASP top 10. This is a generic security guideline. It has 10 security guidelines and these are defined based on metrics, actually, and it's listing 10 guidelines based on the 10 most common cyber vulnerabilities. So it's drawing your attention and your focus towards the 10 most often cyber vulnerabilities. It's giving you advice to invest some time there and secure these layers. Now, OWASP Mobile Top 10 is the equivalent, but with focus on mobile applications. OWASP ZAP, the third line. This is a penetration testing framework. It is available. Everything you see here is open source. You will find everything on GitHub. So ZAP is a penetration testing framework. It's similar to the Burp Suite for those who work with frameworks, with these frameworks. The great with ZAP is that it's provided out of the box in Docker image. You can download directly. You can pull directly the Docker image from Docker Hub, and you can deploy it easily. You can try a local dev test. There are many videos on YouTube that are explaining you how to get started with a OWASP ZAP. What do you do with ZAP, and where's the value? And Anton, I think he will demonstrate a few things later on, maybe not with ZAP, but we will show a couple of CI/CD aspects. The great thing with ZAP is that you can use the Docker implementation of it, and you can implement it and integrate it in your CI/CD pipelines. So you can make automated penetration testing, automated security testing after your build phase in your CI/CD. So that is amazing, and it's open source, provided for free to everyone, and ready in Docker image out of the box. Now, OWASP Docker Security. This is a new initiative. This is the Docker 10. It's a new initiative. It's still work in progress. You can click on the links. I think you will get the presentation after. You will get the presentation notes after this meetup. So the OWASP Docker Security is a new initiative. It's called Docker Top 10. It's still work in progress. So it's open source, and everybody is invited to contribute. What the team is doing there is they're analyzing and collecting metrics and studying in depth Docker security aspects, and they try to make the top 10 Docker security concerns and configurations and security hardening recommendations. Now, OWASP SKF after the Docker one. So this is the security knowledge framework. This is called OWASP SKF. Is one of the flagship projects of OWASP. The inventor of this project is a friend of mine. I hope that I have the chance to invite him. Maybe we can organize something larger in the near future together with Anton. So what is SKF? SKF in practice, Security Knowledge Framework, is a small Wikipedia, allow me to use that term, is a small Wikipedia that can be connected automatically to your CI/CD pipeline into your automated security and penetration testing there, and can receive the logs, and based on these results from your CI/CD, it can automatically prompt you. So based on the findings of your automated penetration testing instance, based on these findings, SKF will prompt you directly to the knowledge you need to resolve a security vulnerability. For example, let's say that you made a C# application and you implemented ZAP in your CI/CD, which is the penetration tester of OWASP. And let's say that ZAP identified that after the build stage, of course, after the build and deploy. So let's say that ZAP identified what vulnerability? Let's say that identified vulnerability in injection, some kind of injection vulnerability. So what will happen is that it will send a message, or the SKF will aggregate the log there, and SKF will automatically open a ticket for you where it will prompt you, or it will give you directly the knowledge how to mitigate and how to resolve secure your code to protect against injection attacks. Now, what is the value here? The value is very high of SKF because exactly no one is a live encyclopedia. So you can never know everything. So sometimes your penetration testing can have findings that you do not know how to resolve, or maybe you are not aware, you don't have deep knowledge on them. And there is where SKF comes into the picture. We can proceed. Now, Defect Dojo. Some of you may be working in small, medium, or larger companies. You may have heard of Jira or Trello. So these are project management tools and agile management tools. So as we know, and Snow, some other knows the ServiceNow, Snow. So all these are in practice are ticketing tools. So you have tickets or user stores created and assigned on the name of some engineer to resolve. Now, OWASP said, let's create our own, and there's where Defect Dojo came. So Defect Dojo is a security management system, and again, that can be integrated well with SKF and with OWASP ZAP penetration testing system. And Defect Dojo automatically creates the ticket and assigns on the available engineer, or maybe can let it open until it gets assigned. So it can also alert some service manager or directly some engineer, or maybe you, if you want to play with these components and integrate them at home and at the dev test environment. So what it does, it creates, based on the finding, it creates an open ticket that we have an open security vulnerability. So this needs to be resolved. When it is resolved, you go and update the status of that ticket, that user story, to done. And it can be integrated with SKF as well. So you have the ticket in place created, and you have the security vulnerability mitigation recommendation in place. So findings with ZAP, creation of ticket with Defect Dojo, and recommendations how to resolve your security vulnerability with SKF. Let's go to the next one. So you can always find more at OWASP.org. They have a lot of projects. Here we just collected, these are among the favorites in Europe. However, if you like other programming languages, they have also a lot of Java stuff there, JavaScript as well, a lot of JavaScript references there to secure your front end or Node.js code. So give it a try, visit OWASP.org and explore this wonderful ecosystem of security. We can go to the next slide. Now, the OWASP top 10, which was the first bullet point we presented in the previous slide. So these are the, in 2021, these are the most common security vulnerabilities. And this result is made with a consolidated delta from what are the most common cyber incidents. I see people are waiting in the lobby, but the admin is taking care of that. So the OWASP top 10 is a consolidated list which is taking into account most often incidents, but at the same time higher security risks. So they put all that in a nice list of top 10. So I will just give you one line per each item. The injection. The injection is not just the SQL injection, the famous SQL injection, but it's any kind of malicious injection. In the older-fashioned systems like CMS systems that are not updated, or maybe they were created 15 years ago. So SQL injection was a real threat back then. Now, injection is any kind of malicious data stream that is submitted either through a graphical user interface on the web, so from an HTML form, or is sent to a Restful Api as an HTTP stream. So any kind of malicious injection, whether that injection is targeting a database, or is targeting a backend service, or anything else, so any kind of malicious incoming stream, that's the type of injection cyber threat. Now, broken authentication. Broken authentication, and we will talk more about that in the next security slides I've prepared for you. The broken authentication, in simple words, is that at application level this time, so you remember the layers from the security layers slide we saw before. So this time we're talking about the application layer, logic layer, right? Broken authentication is when your logic there has not taken the necessary measures to authenticate properly. It means that it's vulnerable in unauthorized and not authenticated access, which means that someone who should not access your private data now is accessing your private data, and this data can be either leaked, exposed, or even modified or deleted, so they will no longer be accessible or reliable. Now, number 3, sensitive data exposure. This can be the result of a broken authentication. Why do they make a special line for this? Because not all data have the same value. So, for example, credit card numbers or insurance identification, these are called PII data. They have among the most serious value in all the regulatory compliance frameworks, in banking world, in finance world, in e-shops, in other enterprise appliances, supply chain management or fleet management, any kind of things, up to government appliances, right? It doesn't really matter what's the type of the appliance we examine here. So sensitive data exposure is the cybersecurity incident that critical value data got exposed. So after that exposure, it means that they can be replicated somewhere that they shouldn't be exposed, or your data can be deleted or modified on purpose. Now, XML external entities, XXE. This is prompting to old-fashioned and outdated applications. Some very old-fashioned applications that were relying their validation on XML entities. What is happening there is that the XML has an entity which is called external entity, and that entity can create a vulnerability that gives to some unauthorized external malicious entity access to private data in your local file system. So XXE can compromise your file system and expose your files. Broken access control. Now, when we work in a company, or even when we are consumers of our favorite application, let's say Twitter. So broken access control is when the organization, remember the slide before, the external or physical environment, the organization layer, human layer. So when the physical environment is not applying the right security strategy. So broken access control is, let's say that we created a new social network and we didn't take the right measures to authenticate our users. So we have some registered users, but some other unauthorized can access the data of the private data of the normal users. So when the organization doesn't take the necessary security measures to secure all the layers and at the end the data, this is a broken access control. So it's not applying the best security practices, leaving your application naked. Security misconfiguration is part of number 5. So when you don't apply the right security policies, obviously your configuration will not be secure. Cross-site scripting. I will also, because we may not have too much time, so I will try to summarize this. So cross-site scripting is the security incident where your system has been compromised and now malicious code is distributed through your web graphical user interface, your website. So you can have your website, best case scenario, your website can be hacked and the content can be altered, but In the case of cross-site scripting, your website might be redirecting users somewhere that phishing is performed. So someone is trying to extract from users to persuade them to put their password somewhere, and then someone is stealing all the usernames and all the passwords. So if that incident happens through your phone, that is cross-site scripting. Insecure deserialization. So we will talk more about insecure deserialization in the next slide I have prepared for you. So allow me to elaborate then, because we have a specialized slide for that. Using components with known vulnerabilities. I think this is explaining itself. So if you have created your IIS server and you have outdated Windows Server operating system, and you didn't install all the patches, so you didn't apply all the patching according to Microsoft's schedule. So obviously that system is using components with known vulnerabilities, because exactly you didn't install the security patches that mitigate the discoveries directly by the provider. Insufficient logging and monitoring. So even if we do the most secure code and infrastructure in the world, let's say that we work 6 months and we make something which is amazingly secure. If you don't have sufficient logging and monitoring in place, you are blind. Your systems can be compromised and you don't even know about it. So we always need sufficient logging and monitoring. And allow me to expand this one. We probably have a specialized slide for that. So I will elaborate there. Just, it's not only logging and monitoring. So allow me to speak more in the specialized slide for this scope. We can go to the next one.
Okay, and if I remember correctly, this one will be mine. So Iris just told you guys about the OWASP Foundation, and here I would like to talk a bit more about the thing called Stride. So Stride, that's basically the same view, but addressed from a different viewpoint. That's the Microsoft way, or like the Microsoft model, how the Microsoft actually modeled all the security vulnerabilities and how they group them and how they provide the recommendations of basically how to handle them. So Stride means spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So in each of those groups, that can be different kinds of attacks that's basically addressing this or that security vulnerability in general. And I would like to go next and show you basically this slide, because there is a tool that you can use. Because what we stated also at the beginning is that, let's say that you are a developer or a DevOps, or let's just use a general term, you're an engineer and you want to basically start working with security. But in one hand, you understand that, okay, I probably should not store my passwords in a clear text. That's for sure. If you will not store your passwords in a clear text, you will contribute toward the security. But is that it? Maybe it's something also bigger behind it. And this is the tool that I want to show you right now. This is the free tool. It works only on Windows OS. So if you're on Mac or Linux, you probably need to do some virtual machine or something like that. But anyway, let's jump right to the demo and I will show you basically what this tool is about. I already have it opened here. So this is the tool, Microsoft Threat Modeling tool, and I already created a model of my environment. So I will do open a model here, and this is my new threat model here. Okay, so I don't know actually how you can see that. Is it a good or bad? But I assume that the zoom level is okay for you guys. So what we can actually see on this screen within this tool, on the right side, I have basically a list or like a collection of different components, different building blocks that I can use to build the infrastructure of my system. And as you can see, of course, because the biggest expertise I have will be for the Azure cloud, so that is why I use the Azure template, and that is why all the components here are in this or that way are related to Azure. Okay, so what I have here, I have a browser. So let's say I'm working with the web app, and as you can see, this browser is located in local user zone. It means that I cannot control that device and that host, which basically end user uses to access my application. Let's say that we're talking about a public facing website, not a B2B or like internal enterprise application. So next I have the web app, and that browser will basically send the request to the web app, and also, oh, that arrow should be actually like this. Yeah, let me fix it. Okay, and from that web app, that will be the response which goes back to the browser. Then that will be another web app, but this web app will host my API. So my front end will also run some requests against my API, and here I have my SQL database. So this is pretty much easy and straightforward process how you actually model your environment. But let's say that you're done, and let's say that now you want to understand what your security vulnerabilities may be for this setup. So what you can do on top, you can click reports and then create full report. I will generate a report. I already have a few of those, but let's call that test 03. Okay. And this is basically my report. Let me just zoom it a bit. So what you can see here, you can see the threat modeling report of that infrastructure that I modeled. So in total, it found 31 potential vulnerabilities for this specific setup. And if I will scroll lower, it will show that, okay, so for this particular region, for this particular interaction, for the request, those will be the vulnerabilities that I need to address. For example, the category elevation of privileges and the kind of a description of an attack. An adversary may abuse weak Azure SQL database configuration, and the priority is high because the impact is high, and so on and so on. I will not go through all that list, but the key idea here and the key takeaway here is that if you want to address the security of your application, if you want to improve on the security, feel free to use this tool, feel free to use Microsoft's threat modeling tool, because what it will create for you, it will create for you basically a checklist. And then you will be able to go through that checklist and actually say, okay, I do have this vulnerability. Did I already address that? Yes, no. If yes, you can mark it as done. If no, okay, then you can investigate, you can find some more information about how to handle that, you can fix that, then you mark it done and go to the next one. So this is one of the biggest advantages of this tool. Let me just probably show you some other examples here. Yeah, so for example, that maybe some attacks that works on a response level as well. So this tool will actually help you to create the checklist, and then, as I was saying, you can go through the checklist and you can improve upon the overall security of your application. So yeah, that was it. And if I remember correctly, Iris, the next part of the presentation is yours.
Yes, thank you, Anton. Also great, the chapter you just presented. So I saved a couple of bullet points before in the OWASP presentation to tell you more with some focused slides I've made. And For those who might be a little bit more advanced, so in this meetup, we try to cover a broad audience. So starting from high-level architectural aspects, but also we want to satisfy the interest of some members that may be more advanced in the field. So I think I will get the opportunity in these slides, so getting into some basics, but also maybe give you a couple of more advanced notes. So let's go to the first one. So sanitization. Unfortunately, many with respect to every approach, and it's not a matter of knowledge, but unfortunately, I've seen in a lot of teams, even professionals, that they underestimate the sanitization concept. So what is sanitization? I'll start. I promise to start from the basics, so we can cover all the audience, every audience, and I will have the chance to give you some more advanced notes here. So what is sanitization? Sanitization, as you can see in this very complex diagram, so is when a malicious stream, for example, through the network or from the web, so an HTTPS stream. So a malicious stream is input and it reaches our application layer. Remember the slide before, the security layers. So let's say that we didn't have any firewall or web application firewall at infrastructure level. And let's say that this malicious stream could make it inside. So now it reached our logic. So sanitization is the functionality at application level, which is neutralizing the malicious data. In the OWASP top 10, you saw a line talking about non-secure deserialization. What does this mean? The more advanced already know, but allow me to recap. So what is insecure deserialization? When data is transmitted from the web, this data is encoded into HTTP stream. Many of you see JSON when you work with RESTful APIs, but in reality, your data is not traveling as simple JSON. So the actual transmission is called HTTP stream. Now, all the programming languages, they created API and functionality to be able to get connected to networks and exchange data in this way. So there is where the concept of serialization and deserialization created. So what is serialization and deserialization? Serialization is taking the data from an active instance in your RAM memory, an instantiated object that holds data in the RAM memory. So taking that data, processing it, and render that data into some static format. For example, you can close all the dynamic data into a final string value. In that string value, you can have your JSON definition that you want to send to a RESTful API. What is now deserialization? When you have created a RESTful API that is receiving data, so when you receive that HTTP stream and it reaches the API of your application, taking that, parsing that JSON, so reading that JSON, and then instantiating it in your RAM memory, that is in reality the deserialization. So some static and not live in reality data, now this data got an actual instance inside my system, and not just in my logic, but this data now exists as an object in my RAM memory. And that is the deserialization. Now, sanitization, we can apply sanitization in many strategies and in many ways, but I will elaborate on the most common strategy and the most common need here. When we exchange data on the network, on the web. So when our application receives data, sanitization is the process that is mitigating cyber threats that may be contained in that HTTP stream. So what sanitization is doing in reality is instantiating the data coming from the HTTP stream. It's instantiating it in a separate area in your RAM memory. You can even make that area as an isolated vault if you really want to dive deep into that. That would be an ideal sanitization. But to come back into more common and everyday scenarios, even if you don't isolate, virtually segregate an area in your memory, let's say that you just want to instantiate that data. You can still apply sanitization strategy there. So you filter the incoming HTTP stream and you neutralize there the cyber threats or malicious data that may be contained there. And how do you do that? You do that by instantiating that data in a memory slot that is not used directly by your critical logic of your application. But what happens is that that data is instantiated temporarily in your memory, and it's filtered with a proper filter. I will talk about the filters now. It's filtered, and then that data is reinstantiated in another data container in your RAM memory, which is clean. So if the data that you received from the HTTP stream is legitimate, then the sanitization will probably do nothing. It will not modify it. But as you can see in this very advanced diagram, if the stream is malicious, what will happen is that your sanitization module in your code, it can be a method of a class, right? So it can be a function. So your sanitization module will turn a wild it's tiger, probably it's tiger or lion. So it will turn it to a very cute kitty cat. So now, what is actually happening? Because I said you instantiate that data temporarily in another data container in your RAM memory, you filter that data, neutralizing the threat, and then you reinstantiate it in a memory which is directly now processed by the rest of your application. So in the second instantiation of object, which is already filtered and the cyber threats are already removed, that object is then that object can be consumed by the rest of your logic. And I will explain you what can happen if you don't do that. Now, what is the filter model? What is the sanitization model? It can be as simple or as you can become as diligent and as advanced as you like. But let's start from the basics. Every programming language in 2021 has out-of-the-box native function that is doing at least some basic and many times very sufficient sanitization. In JavaScript is the one that is encoding URL characters. I don't recall the exact syntax. We can find the same or similar in every programming language. What it's doing is it is simply escaping some special values. So if the incoming stream is malicious and it includes some kind of script, what the sanitization module is doing there is neutralizing, is actually encoding, so or deleting or killing the characters that can activate that malicious script inside your runtime without you knowing it. Now you will tell me how the hacker and the attacker knows what kind of runtime you have. They may know, they may not know. So there are a lot of variants in the cybersecurity and cybersecurity threats. Let me bring you an example where a hacker already knows what is he or she attacking. Sometimes many of you have opened the browser and have opened the HTTP analysis tool of your Google Chrome or Firefox. If you go and open Facebook or call LinkedIn or Twitter, if you go to the HTTP analysis and you click in the first HTTP response, so before the subsequent HTTP responses come, so even before the DOM rendering, the OM rendering at the client side, before that, we don't care about that. Whoever is using CURL in your CLI, so it's the CURL command that is only checking the availability of a website, so returning the status code HTTP 200 or some other error message. All right, so if you go to your browser in your HTTP analyzer and you click on the first HTTP response, all right, so clicking on the response and going to the HTTP headers of that response, sometimes you can see the name of the type of the server that is replying to you. So I can see Nginx there. So some people will tell me that, fine, security is not achieved by obscurity. So I don't care that I'm exposing that I use Nginx, because simply I have taken all the other cybersecurity measures and I don't care. This is not necessarily wrong, but not necessarily ideal as well. Not investing in security by obscurity, and I will explain that term in case someone is not familiar with the term. Not investing in the security by obscurity is a direction that you will take when you cannot practically ensure that aspect and that strategy. So when you have a huge scale, Microsoft, for example, and you have a lot of virtual instances that are handled as not necessarily as permanent environments like a private cloud or on-premise, but are handled as ephemeral environments. For example, a cloud function on Azure, right? So Microsoft there is not afraid to expose that that the HTTP response is given by an Nginx proxy, because simply that is an ephemeral instance. So it will be deployed just to pick up that HTTP request, do the processing, create some other event inside Azure, or maybe reply some result as an HTTP response. It doesn't really matter. It can be a webhook that is going to trigger something. That doesn't really matter. So if it returns an HTTP response, Microsoft doesn't care to hide the proxy there, because exactly that's an ephemeral environment, and also Microsoft is investing very large amounts of money to secure. So they don't need to invest in security by obscurity, but at the same time, that is not practical to do at that size and scale of business. However, let's say now, let's take an opposite example, that you have a startup and you don't have very large budgets to invest in security, so you have to do it on your own. So I suggest that you do invest in security by obscurity, and you do not expose, if possible, not expose any kind of information. Because if in the HTTP response, I see that you are replying to me with an Nginx, some hacker can invest time to try send to your API some malicious script, assuming that you could potentially not have sanitization, and it could contain a single character that can kill your server. There are specific special characters that can bring down Apache server, they can bring down Nginx server, probably they can bring down many other servers. So there is where the attacker is investing to succeed the hacking goal. So now, what is the term security by obscurity for those who might not be familiar with the term? It means hiding not necessarily sensitive information, but hiding any kind of information that can expose your architecture. So the fact that you are using Nginx is not necessarily classified or top secret. All right, it can be exposed, and you can secure it perfectly, even if you are exposing that it is. So even if you are exposing the Nginx token, all right, and someone knows that you are hosting your application on Nginx. So, but when you're small, when you're a startup and you don't have all the necessary funding resources to invest and grow a very mature security fast, I suggest that you also invest in security by obscurity. Security by obscurity means that you hide also every other information that is possible to hide, even if that information is not business critical. For example, what kind of server you are using. If you can hide that as well, because if you expose that, you expose one part of your architecture. And if I am a hacker and I start reverse engineering your architecture, you just gave me the first tip for free. And this is how an attacker can know, can get an idea of what is he attacking. So in a malicious stream injection attempt, someone will attempt to send to your server a bad character, hoping that he can bring down your server. So kill your server, and then you have unavailability of service without even DDoS attack. So with a single HTTP request, you can bring down a server if it's not secured properly. Sanitization, I recap, is the process that you filter and either encode, so a bad character, a dangerous character, change it to another not dangerous character, or even remove and delete if it's a more sophisticated sanitization program, maybe something that could also be using artificial intelligence. So either encoding, which is called escaping. Escaping is just taking character, whatever, dollar, and convert the dollar character into hyphen. All right. So that is an example of a custom-made sanitization, because the dollar character in many programming languages and servers, server runtimes, it is symbolic for a variable. So it will try allocate in your RAM memory, instantiate a variable, which is also an object in a data container in your RAM memory. And after that, a lot of things can happen. Other malicious characters can be characters that can kill the runtime. So, for example, I have seen that. I've done a test many years ago with Apache. In Apache, you can easily send some specific character, if not more, if at least one, if there are not more of them, that you can submit that from a Restful API or from a web form that can bring down the Apache live during the runtime. So it doesn't need to restart, it doesn't need to redeploy, nothing. It's already deployed, and if you don't have sanitization, that will kill your server and make your website and application unavailable. So this is the aspect of sanitization. As promised, I tried start from some basics, but I tried also dive into a little bit, maybe not too advanced, but a little bit more advanced aspects to satisfy also more experienced colleagues that have joined this call. So we can go to the next one. App security aspects, data validation. And let me put a parenthesis before I go to this one. I started presenting the previous slide by saying, unfortunately, many people underestimate sanitization. Are these bad engineers? No. Are these not diligent, not working hard enough? No, it doesn't have to do with any of that. Most of the times, the security architecture is missing either from the standard strategy of an organization, and if an organization invests in this strategy, it can turn that strategy into the everyday mentality of the engineers. So when an engineer does not apply proper sanitization and some other small mitigation strategies that we will see in the coming slides. So when an engineer doesn't apply this, doesn't necessarily mean that this is a bad engineer or doesn't have the knowledge. Maybe he's not given enough time to create high quality code. Maybe he's on a very short deadline and needs to deliver in 1 hour, and the project manager is pushing him. it doesn't matter what the case is. When an organization adopts the best security architecture and practices and invests turning them into must standards at from project management level up to engineer everyday mentality. So if an organization takes the time and invests the necessary, it's not, I wouldn't say funding, because this is not about money. So it's just about direction. So taking the decision that I want to invest towards security optimization. So if an organization does that, they can simply put these practices and these approaches, create them as standards. So standardize the process, and then you will always have sanitization, you will always have validation, authentication, encryption, and many other things that we will talk in the next slides. So data validation, I believe everyone knows in this call what data validation is. Data validation means that the data that my RESTful API received from a publicly exposed point of interaction or endpoint. For those who might not understand the difference, so endpoint is a RESTful API at the box on the left that I say public POI / endpoint. So endpoint is a RESTful API, publicly exposed. POI is a point of interaction. Point of interaction can be either API or a graphical user interface. For example, the Facebook login page. So what is the data validation? If your backend API on the right requires, let's say that you architected your logic in a way that it requires the entire email of the user, including the domain. Okay, including the domain. If it doesn't see the domain, so my name at facebook.com, just an example now, all right? So let's say that your backend API, it doesn't have in the logic this kind of validation to understand if the domain is missing. And let's say that a user used directly their proper username, maybe it's the correct username, but they forgot to add the domain. So it's username without the @facebook.com. So if you don't have data validation logic in your application, what can happen is either the user will have a bad user experience, will not be able to authenticate to your service. So I'm just bringing one example with authentication here, right? But we can make dozens of data validation examples. So in your logic, in this small example, you must have appropriate logic that can understand when the submitted data is actually username, if it requires to have the domain, then it should validate that on the front end and return a message to the user that please add the domain, or maybe you can automate all that and make a more sophisticated logic that understands if that's a legitimate username, and if the domain is missing, automatically add the domain. You probably have experienced that logic a lot in your emails authentication. So when you try to authenticate to a famous email, I think Yahoo is doing that, but I'm sure most or all famous email providers are doing that. So on Yahoo, if you try to authenticate yourself, you do not need to include the domain. You can authenticate with your username only, without domain, but you can also type it full with the domain. So that is a more sophisticated data validation, because it's capable to understand whether that data is junk, like you see on the left, or good quality data. What is good quality data? It's valid data. So if that input is expecting a username, it should be a username and not an attacking script. Why don't I have the attacking script in this slide? Because we eliminated it in the previous slide with our sanitization. So before, and here I want to say this also to the experienced developers. No, data validation does not replace sanitization. Sanitization must be the very, very, very first step in your logic before anything else you do in your code. Do not rely on the web application firewalls at infrastructure layer. Even if you have the best and most secure infrastructure in the world, even if your logic is hidden behind VPN, you should still adopt the security strategies we present here today. Because in the rare scenario that the infrastructure and the organization layer will be compromised, the cyber attack will reach your application and logic, even if that's isolated in a private network or private cloud or on premise behind a VPN. Encryption will not protect you there. Without validation and sanitization, the rest of security measures will not protect you there, and someone can either get control into your systems, bring your systems down, or something worse can happen at data level, compromising your data. We can go to the next one. Now, authentication. This is very simple. I will not spend our time in this one. So, authentication. I want to address this at high level architecture view. So, when you build systems, and this has to do, this depends on the value of your data. Obviously, when you create a system, a RESTful API that is exposing data, and these data are meant to be publicly exposed, obviously, there is no authentication required there. And someone will ask me now, but in 2021, are there systems that do not require authentication? Of course there are. For example, a RESTful API, which is providing you every second or every minute the weather data. So that API is supposed to be open and is supposed not to require any authentication. And now you will tell me, but it's open, so it's vulnerable. No, it's not, because you can still absolutely secure your open APIs. Maybe we will schedule a second call in the near future where we can dive deeper into more security strategies. If I start elaborating on everything, I think I will get all the meeting, and we will need double time today. Authentication, to close this aspect here, authentication is simply the process that from a publicly exposed either endpoint or point of interaction, if it's a graphical user interface, if it's a login page. So it's the process and the logic and the architecture in your system that you validate, not the data this time, not the ethics of the data this time, but you validate if that entity is registered in your identity service. So you validate if that entity is recognized by your identity service in order to let that entity access your backend private data. We can go to the next one. Encryption. We didn't have time to make the most sophisticated slides in the world. Apologies for this, but I promise in our next time to bring some challenging, even for the most advanced material. So encryption. I will not start getting into too deep detail. If you develop something in 2021 or you maintain something in 2021, you should have nothing less. Change it now. Escalate to your boss now. If you respect your profession, if you like cybersecurity, if you want to protect the data of your client, so you should have nothing less than what you see in this slide. You can have anything more than that. So have that and add on top of that anything extended you like in terms of encryption. You can have secondary encryption layer. You can have VPN, which is extra encryption layer. So you can do a lot of things, but you should never do less than what you see in this slide. And to close it in one line, the RSA either 4096 or down to 2048. This is the standard, today's standard in appliances for web encryption. So this is the famous data in transit. What does this mean? This means when data is transmitted through a public or even private network. Now you will tell me, but I have a VPN. Why should I encrypt my data inside the VPN? Let us catch up on this in a next meeting that we may organize, where we can dive deeper into more advanced strategies. So the RSA, the 4096 is the heaviest today's encryption for HTTPS. Sometimes reduces the performance, so you can drop down to 2048. So that depends on the criticality and the value of data that you are transmitting. For example, let's say that you transmit over the public network a key which is critical. For example, it could be decryption key, of course that it's not decrypting the data you are sending at that time. But let's say that your RESTful API is calling another API to retrieve a key in order to use that hash to authenticate programmatically itself versus another third-party system. That is a case that you transmit a key over the network. So if you do the transmission, because this key is an access and security critical key, you should transmit that with RSA 4096 and accept the performance reduction, because exactly you are transmitting critical data. If you have a banking application which is using insurance number, identification number, passport number, so many PII data. For those who may not know the term, the PII data is private identifiables. I don't recall the entire term here. Somebody can drop it in the chat. So PII is private data, in short. Private data. So these are critical data. It can be your insurance number. It can be your medical records. So if someone has a disease, that is a very private information. That information should not be leaked to any third party, and that's why doctors keep this data isolated and never leak data like that. So when you transmit critical data of critical value over a public network, you should never do less than RSA 2048, and the more critical that data is, and the more you can afford performance reduction, use RSA 4096, which is the heaviest encryption standard right now that you can use in public data transmission. And now let's go to its cousin on the right, which is the AES 256 bit. By the way, for those who may not be experienced and familiar with all these terms, these numbers are all bits. So it's 4096 bits, 2048 bits, 256 bits. I will give you one line why bits and why does this all this thing matter. And the AES 256 bit is the latest standard for your data at rest. So on the left, I talked about data in transit. So when I transmit data over a public network, when I transmit my data over a public network, I use HTTPS, TLS. This is asymmetric security encryption. Excuse me. This is asymmetric encryption. Asymmetric encryption means that there is also a publicly shared key apart from the private encryption key. Now, when I have my data, so this is data in transit, when I transmit data, but when I have my data in my private server and I want to store them in my private hard disk, this is data at rest. So data is resting in your storage. So there, you do not transmit the data. This data can be fully isolated. So the latest industry standard to use to encrypt your data there is the AES 256 bit. One more important aspect of the encryption is the entropy. We will dive deeper in another session in the near future. I would love to take you into very deep knowledge of entropy. I've personally been involved in innovation, creating your own key vault, for example. I have tried to create my own private key vault. I mean, coding the entire key vault yourself. So entropy, in simple words and in short, is the measurement of difficulty someone, or maybe an artificial intelligence or a program, to guess your key. When you Google this term, you will mostly see discussions about passwords, because passwords, user passwords, are also keys. So when we have a string value, the length is not the only thing that increases the entropy. For those who use web banking, or maybe you have seen some tutorial about making your password more secure, you will see recommendations that they tell you to use uppercase letters, lowercase letters, numbers, and symbols. Why they tell you to use that, and why they tell you that your minimum password length should be 6 characters or 8 characters? Because if you make it at least 6 or 8, and you mix the characters that you use in that string value with uppercase, lowercase, numbers, and symbols, what is happening there is that you mathematically increase exponentially, not linear increase. Exponentially means that you can suddenly increase it 2 billion times. So exponential increase is a sudden increase. So step 1, 1%. Step 2, 1 billion% plus. So with the right mathematical entropy, you can secure your encrypted information so well that even a sophisticated computer system with artificial intelligence or any other kind of technology will not be able to hack that secret, will not be able to decrypt the information. So AES 256 and RSA with all the variants here are modern ciphers to use to encrypt your information. And with AES 256-bit, so I talked about asymmetric encryption. The AES is the symmetric encryption. So when we host our data, when we have data at rest, so we host our data on our storage or in a database, so we use symmetric encryption. Symmetric encryption doesn't have publicly shared key. It only has private key, and the private key is also business critical data. So that must also be encrypted and isolated in an at least virtually segregated, if not separately stored in a second hard disk. So symmetric encryption is using a single key, which is a secret. And we use symmetric encryption, like the cipher AES 256, to encrypt our data at rest. So it means our data when we store our data. Entropy is the architectural principles we apply on the key or secret, on the private secret, like the secret key of symmetrical encryption. So entropy is the architectural principle, which means use a larger variable of possible characters, use a larger length. So entropy is the level of difficulty that secret to be guessed by a random generator. And if you have the right entropy, it is mathematically impossible with today's technology to break a secret, whether it's a password or another kind of secret. It's mathematically impossible to decrypt this information, and that is why national security government agencies are concerned in modern mobile applications for communication that heavily encrypt the information that is transmitted, because these applications can also be used by people with bad intentions to commit crimes, for example. because exactly no one can decrypt the information, so you can have two criminals talk to each other, and it is almost technically impossible. It's not 100% impossible. Let's not dive into government aspects, but most of the times it is impossible to get access to that information. We can go to the next slide. Now, I promised to come also to advanced aspects, so not only being in high-level architecture, but also dive into some deeper aspects and make it more interesting. So, what is a kill switch in your application logic? Have you ever? Actually, there are many variants of a kill switch appliance and logic. All right. So I will try to give you a simple example. Most of you have heard of the retry policy. So, for example, you create your Restful API with Node.js, and let's say that you have another HTTP server that is trying to call programmatically your Restful API. A common appliance of this is monitoring. On Azure, for example, checking the uptime, probing. That's the most common appliance of this. So probing on Azure. So you have for example, you have a web application that has your RESTful API or your website there, and you have a monitor that is calling your website to check if your website has uptime. So if your website is still working. So you have configured your monitoring to call every 5 minutes or every 1 minute, or in any other interval you prefer. You have configured your monitor to call that website every 1 minute, let's use for example, to verify that your website is up and running. Retry policy is that when it receives a non-HTTP 200 code, so it identifies that the website is down, retry policy is to try at least 1 or 2 more times. It depends on your logic, what you have configured there. So to try a few more times to validate the initial result. Because many things can happen over the public network. Maybe there is a network outage. So the fact that your monitor says that this website is down doesn't mean that that it really is down. Maybe there is a network outage in your geographical area. But maybe your clients that visiting that website are in another geographical area, and maybe these clients have not lost access to your service. So retry policy validates the result of the initial attempt to avoid false positives. False positive is a fake incident. So when there is no real incident, but you think there is an incident, that is a false positive. And retry policy validates the initial result to make sure that we have or we don't have an incident. Now, now you have a good understanding of the retry policies. Let's go into application logic now. It's very good to use retry policies in your application. It's also sometimes people choose for practical reasons to use the while loop in their code. While loop in your code means, I will just explain it for the people who are not programmers in this call. So while loop is a logic into your code that says that I will not stop calling that website. So I will keep calling it to infinity until that website replies to me. So first of all, someone needs to design in a more efficient way his retry policies. All right. So for example, you can skip the while, not code it with the while loop, but use different loop to code your logic there. And many people will tell you to avoid the while loop exactly because it's dangerous to put your program into infinite loop. And that's why in this diagram, and I combined it with cybersecurity incident this time, and I will explain you how this is related to cybersecurity. So malicious data enters your RESTful API and reaches your backend API, and then turns your system into Inception movie. For those who may have not seen Inception movie to the cinema, Inception movie is a movie that a team of people, a group of people, was dreaming, and inside their dream they were dreaming that they were dreaming. So this created an onion layer that externally there were the real people, but inside their dream they had other consciousness which was believing that they were watching another dream. So let's not spend more time on the Inception concept, but what I mean here is that either with bad code architecture, investing too much in while loops, or by a malicious activity, your application logic can enter infinite loops. And the impacts are very serious and very harmful there. Best case scenario, your service will die. So your service will become unavailable. So it will flood the CPU, best case scenario, especially if it increases. For example, it could increase in a linear way, or it can accidentally do a small, it's not a real DOS attack, but it will accidentally, if it keeps calling the other RESTful API to infinity or your website to infinity, it will accidentally perform not DDoS, not the famous DDoS, but one simple type of DOS network flood or application flood, service flood attack, which is the DOS, denial of service. So if you have a while loop that is calling that website to infinity, and you have a very small interval, let's say that it's accidentally, the code is very bad and it's calling that website every millisecond, I don't know. So what it's doing is it's practically that broken logic is attacking the website. And some people use this kind of programming logic on purpose to create malicious scripts which perform the DOS types of attacks. And the DOS means denial of service, for those who may not be familiar with the term. And DDoS is the, if I recall correctly, the distributed denial of service. And of course, it is because it is distributed. The DDoS means that the malicious script was deployed in many different geographical locations and hosts, can be thousands, and simultaneously with a syncing clock, they all call every millisecond that website. So what will happen in the best case scenario, it will either exhaust network resources or it will hit the security filtering there, so the traffic will be throttled, or it will exhaust the service hardware resources, so your server. And that's where your website will go down and you will have denial of service. Now, coming to the concept of kill switch, I know I gave you a lot of background knowledge on this, but coming to the concept of kill switch. Kill switch is can be either time-based or can be metrics-based. Kill switch is practically a logic that is either terminating, so killing, or throttling an activity. Let me give you the example with the time-based or retry-based, so amount of retries based. So, for example, you can implement in your logic that you have your probe, so you coded a monitoring system, all right? And it's calling your website to see if your website is still up and running. So you can make your retry policy that after 3 times, your monitoring system will consider that there is a valid downtime incident and will stop calling that website. So kill switch is any logic that is either time aware or amount aware or metrics and analytics aware. And it will stop some specific logical activity after a specific threshold. For example, you called your website 3 times, you must stop, your monitoring must stop calling it because for example, it thought it was a false positive the first time. After 10 seconds, it got an HTTP 200. In the third attempt, it gets an HTTP 200. So your monitoring has a kill switch logic there, stops calling that website, and will start again at the next iteration of the interval that you have configured. Now, why your kill switch is relevant to cybersecurity? Now, we talked before about malicious streams, and if you don't have sanitization, and if you don't have validation of data, that your system can misbehave or crash. Now, how kill switch can help you there? If you don't do data validation, proper data validation, and you have a while loop checking if the username has domain inside that string value, what will happen is that you will have an instantiated object in your RAM memory occupying your CPU. So this time, that loop, that forever loop, will try exhaust, depends how heavy it is, it will start exhausting or consuming significant resources from your CPU this time. So that is why even if you use while loop, you can still implement above that. So it can be a function, but you can have a controller which is dominating that function, and the controller has a time-aware kill switch that time. So going back to the cybersecurity example, some user, so not necessarily a malicious person, or maybe a hacker has understood that your system doesn't have proper validation, so it's just sending false data, and it knows that this false data simply killing your server, not because it has characters, wrong characters, bad characters this time. So he is only sending lowercase letters, no malicious characters this time. So what is the hacker targeting this time? It's targeting your logic vulnerability. So security vulnerability doesn't always have to do with firewalls and filters. A bad architecture, a bad logic can also be vulnerable. So this time, the hacker was simply submitting in your web form, a login form of your eShop, was simply submitting usernames, valid usernames, clean string values without any weird characters in, just submitting all the time usernames that do not include in the string value the domain. And because the hacker has understood that this is exhausting your resources, because you have a while loop there checking forever when that user will submit a valid username, because exactly you didn't do proper validation logic before that, and obviously you had a while loop without some kind of time-aware kill switch. So how can I securely use while loops? I must simply have outside of the scope of the while function. So it's a child scope. I must have a more global scope. I must have a kill switch controller which is time-aware. And that controller checks the instantiation of objects in the RAM memory during the runtime of your program. So it monitors and checks probably the highly how would we design that would be to make it check the risky object. So if we have an object that we know that object is using a while loop because we needed it for any reason, so we make a kill switch which is monitoring the clock. So it's monitoring the time, how much time that object is instantiated in the memory. If you want to make it even more sophisticated, you can check how much CPU is that consuming and place throttles in the CPU as well. Or a very simple logic kill switch just will terminate that function if it's active for 1 minute and it didn't return the result, the data that it should return. And this is a simple example. I tried to simplify it as much as where this was possible, but this is an example how a bad software architecture relates to cyber security, because your cyber security vulnerability this time is simply the logic and the architecture of your application rather than anything else, because we can bring down that application, so somebody can hack your application by sending legitimate and valid data. So simple string value, only letters, only lowercase, nothing weird there. Still, they hack your application if your application does not adopt these strategies. And let me give one final example. Anton, I know I'm taking a lot of time, but I hope you guys enjoy this session and find something interesting. Let me give you one more example of the CPU exhaustion, because you will tell me, but a simple while loop that is just checking all the time the username if it contains the domain, because your logic demands that this is just occupying a small percentage of my CPU. Yes, of course, and depending how it is coded, all right? But what if your logic that is using the while loop, or maybe it's using some other non-time aware logic, because you can create dangerous code, dangerous for itself, even without while statements. So it depends on the logic, all right? So what if the instance that is not, it doesn't have a time aware kill switch at the external scope to manage it, right? So what if your code there is doing some kind of processing of data, financial data of supermarkets, 100 supermarkets, for the last 12 months. So this is how this can keep exhausting significant amount of your CPU, RAM memory, hard disk, EOPS, input output messages, and exhaust your hardware resources. And for those who like Azure DevOps, some of you have possibly seen that there is a maximum. You can also configure it as far, if I remember correctly, you can also customize it. So Azure DevOps, when you have a pipeline there, it's not allowed to run to eternity, because you might have done some kind of wrong logic, or maybe some service of Azure is down there or not responding. So what Azure has done there, Microsoft knows this strategy, and they adopted this strategy. They know that, and they apply it already. So they have a kill switch which has full access rights not necessarily in the data of your pipelines. It's not that kill switch doesn't care about the data. So what is this kill switch is monitoring the instance of that runtime. So for example, if in the backend is a Docker container, so it's just monitoring how long that Docker container is active without specific input-output action. And it says, if it exceeds that amount of time, I just terminate that instance. So I terminate that pipeline. Here is an example in very large enterprise architectures, how Microsoft is applying kill switch strategy. We can go to the next one. I will not elaborate too much, because I think I took all the time from from Anton. Apologies, sorry, Anton, for this. So error handling. Without proper, and you remember in the OWASP top 10, the last line about saying non-sufficient logging and monitoring. Many people think that logging comes from the monitoring, from the probing. So what is logging? What is logging? Logging is the logs that the monitor made. Right? Wrong. Logging exists at all the layers of our information technology system, of our information systems. Exists at infrastructure layer. We need to implement the best logging practices there. Application layer, and every other. We can have logging relevant to data. We can make a lot of things. Logging relevant to access. But there is a misconception, an architectural misconception, that logging only relies on your monitoring architecture. Very wrong. And that you have automated frameworks which are doing tracing and performance checking on your application. Absolutely wrong. Error handling is the strategy in your code, is another architectural aspect of your application that when your application does not get the expected result, and here I'm not talking about unit testing, I'm not talking about assert equals and stuff like that. I'm not talking about static scanning or post-build deployment testing. No, because there will always be something that you didn't predict in your application. There will always be the modern information systems, the modern enterprise systems are huge in size, scale, and complexity. So the most simple thing in the world you should have in your code architecture is proper error handling. A very simple, if that's not provided out of the box natively in a programming language, for example, Node.js provides some level of error handling, but it doesn't. It allows you to make it more sophisticated yourself if you like. All right. So the most simple example in the world is just to have an error handling class with error handling methods, which can have the most simple logic in the world, that you place it in your loop, in your code, some code logic, and if it doesn't receive the expected result, that it's logging, so it's printing, in practically it is printing, in the error standard output, it is printing the error message. Now, you will tell me, why do I need that? Because my framework or my programming language provides sufficient error messages, even with me, even when I don't make sophisticated error handling. You should invest in that, because if you invest, it's not a lot of time. For those who do software programming, it's an easy thing to do. You should invest time in this strategy, because simply you can customize your error handling strategy to the needs of your project. You're a startup, for example, and you want to categorize your logs into special types. And I don't mean only warning error info from those who do Java and know this type of format. We see the same formatting on Azure DevOps, C# and other programming languages in the Azure DevOps runtime. So no, I don't mean this kind of categorization. Maybe you want to create special tags per situation. So, for example, you had a data validation error in the specific object. Maybe you want to create a special tag that is helping you to identify and trace the difficult situation easily. So if you take time to invest in error handling strategy, it doesn't have strict rules, so you can create your own. You can adapt it to the needs of your project. If you invest the time doing that, then what will happen is that you can easily trace every kind of situation in your system, from security incident or to misbehavior of your application or anything. So proper error handling strategy can save you. It will cost you some time in the beginning, but will save you a ton of time on the go, because exactly it will make your tracing very, very fast, almost instant, depending the logic, because you can also implement aggregator of these logs, or you can utilize cloud native appliances, so they get automatically all these logs, and then you can visualize that and create dashboards, and you can create really sophisticated situations, integrate them with artificial intelligence, machine learning model, processing these data, and making and passing from descriptive analytics and descriptive monitoring to predictive analytics and monitoring. For those who may not be familiar with the terms, descriptive monitoring and messaging and analytics. Let me simplify, because some may not be very familiar with all these aspects. So let me bring one example. All right. So you deployed your favorite application on Azure. All right. And you want to see some dashboards there, visualizing the performance. Okay. Descriptive analytics and logs are those that the incident has already happened and you analyze and study it after the time that it happens. That's the most common globally scenario, and that is what is happening during RCAs, root cause analysis procedures after incident. So what people do, they go study logs and study metrics after the incident has happened. However, here is a good example. If you take the time to invest in efficient and you can make it as advanced as you like. It's up to you to invest time. If you invest the time to make proper error handling and tracing, because every log is a trace, is a digital footprint. So you take that time to invest there. What will happen is that you can pass from descriptive analytics and logs to predictive analytics and logs. So what you can achieve in the end, you can have artificial intelligence forecasting that, hey, I see repeatedly your CPU high the last 5 hours. In my opinion, that is 78% that you will have a P1 incident by midnight. So that is informing you that the incident will happen before it happens. The AI is not perfect intelligence, and it's not an actual intelligence like many people misinterpret and misunderstand. And AI is just a very efficient mathematical concept to optimize handling of vast amounts of data in very short time. And the second one is that you can automate the recognition and the interpretation and the visualization of this data. So artificial intelligence, combining it with a nice error handling strategy, you can make a system that is forecasting risks before the incidents happen. So the AI might tell you the truth or might not, so might give you a false positive, but it will give you awareness of risks and dangers before they happen. So 78% for a P1 incident or for a cybersecurity incident or for unauthorized access. So you still have the percentage above that the incident and the cyber attack will not happen. So there's still a percentage that this will not happen. But 78% is a respectively high risk. So do it. I encourage you to always invest in proper error handling architectures and strategies. We can go to the next one. And thanks a lot, Anton, for giving me so much time in this meetup.
Yeah, thanks. Yeah, thanks. And guys and girls from the community, you just experienced what we used to call back in Valtech the Iris effect. So yeah, but anyway, I know that we are actually run out of time, so my suggestion will be the following. I do have 2 more slides to finish this chapter. So we talk about the design phase, how you can address the security on a design phase, and we're also talking right now about how we can address that during the coding phase. So we'll finish that chapter with my next 2 slides, and then I suggest that we will have basically a break because we announced that that session will be for hour and a half, and we're already speaking for 2 hours. So we should definitely have a second part. But again, let me just finish this one, and that will be the end of the part 1 of DevSecOps. Anyway, what I would like to talk to you about to finish the coding part, I would like to talk about the Azure Key Vault. So those of you who already are familiar with Azure may already use that service. So in general, the Key Vault is basically a way how you can store all your secrets in a secured vault. Yep, and how it actually works and what the key vault also provides to you is that the concept that's called the managed identity. Let me just explain you really briefly how it works. Let's say that you have an Azure VM that can be not only VM, that can be something that you host on top of Azure Functions, Azure Web Apps, AKS, whatever. Let's just consider that an Azure host, okay? So you have your code, which you deployed there, and the Microsoft, from their side, they will deploy the managed service identity extension with the credentials. And the idea here is that they will expose that API only internally. So your code from within that host can call that API and can get those credentials. And those credentials, they are actually backed up by the Azure platform, and that identity is managed by Azure ID. So what you can do next, you can create actually a rule based on your role-based access model that, let's say, I will assign this identity from Azure ID to this specific VM, and then I will allow this identity to access my Azure Key Vault and get some secrets from there. So let's say that you have a connection string for your database stored in Azure Key Vault, and then you have a service identity that you assigned to this particular host. In that way, you can ensure that only that code that is hosted within this host, within this virtual machine, web app, or whatever, will be able to access the key vault, will be able to grab that extra connection string for the database, for example, and therefore go and run all the queries against the database. And again, because we're talking in the scope of .NET community here, so I would also like to show you this one screenshot here, if you're familiar with, and I assume you are, with the ASP.NET library, you know that you can basically configure your own configuration providers. You can stack them, you can basically add them up like in layers, one on top of the other, and there is a library already that you can use as a NuGet package that will basically provide you the configuration interface for the Azure Key Vault. And as you can see here, you need to add only basically a few lines of code to actually start using Key Vault. And here I'm referring to also kind of an important part that we probably didn't touch during this session yet, but anyway, and the important part is how to store your configuration securely, because in your configuration, what you can have again the sensitive data like a login and password to connect to your database, or some keys to connect to the external APIs, and so on and so forth. So if you're hosting your application in Azure, give it a try. Check the Azure Key Vault, because that's the perfect way how you can actually store your secrets and your sensitive data there. On this part, I will actually stop talking, and I do believe that that will be a good, let's say, sum up of this first two chapters, design and decoding chapter. We do have more, so I do hope that Stas and Alex will help us to organize a next meetup where we can continue talking about the other, let's say, areas, the other chapters of DevSecOps methodology, or like culture, if you want, in general. So on that part, thanks for your attention, and Stas, Alex, I will actually give stage back to you.
So here I am. Alex is nearby. I hope he will enable the camera. Guys, it was kind of a bit unexpected, but a great deep dive into the tech. And why it's unexpected? Usually we have kind of more talks on surface, like surfacing the technology, bringing the general concepts, not like deep diving into the roots. And it will be super cool if you will continue to the part 2 and we can easily manage this in 2 weeks, so we can keep momentum, and all our audience will enjoy continuation of this topic. And if there are any questions, is there any questions, guys? Okay, everyone probably a little bit tired, but the main question here, do you have real projects where DevSecOps culture is implemented? Because from my perspective, it's a lot of kind of back pressure from the customer, and customers often doesn't rely on using this approach, and there are a lot of questions why we should do anything about this, and why is it important, and why like standard measures of Azure or standard tools is enough, and maybe these tools is not enough. What do you think?
Yes, so I will probably start first. So I do have a bunch of projects where we started with DevSecOps at the beginning, basically from day one, and at the end of the day, it pays off, because when you are talking about the huge enterprises, yeah, in those enterprises, they do take the security very seriously. And one of the reasons is that, for example, if they're about to store some personal data about the users, and if that data one day will be exposed, then all those users can actually sue that enterprise, and the amount of that, I mean, like the volume of that lawsuit can be really, really huge. So that is why they are investing into the prevention. They don't want to, let's say, fight the consequences later. They want to prevent that at the beginning. So that is why when you are joining a huge enterprise as a vendor or like FTE or whatever, what you will usually see is that they have this department that called the InfoSec department, or just the security department, or whatever, something related with the security. And when you will start planning your architecture, when you will start to, like deploying something, they will always start asking you the same questions again and again. What kind of, let's say, security checks did you run against your application? Do you have any vulnerabilities? Like, please show me the network connection map. Please show me like the firewall and stuff like that. So yeah, in a huge projects, we definitely try to invest that from day one, because as I was showing at the beginning of the presentation, it's much easier to fix on an early stages on the projects rather than implementing that like a day before you need to go live.
Allow me to comment on that. That is also lack of adoption of agile approach. So treating things in the old-fashioned waterfall style, well, everything has to be defined and specified in advance. So you move all the responsibility and you rely all your hopes on what you will do in advance. But modern enterprise or small startup information systems and applications have higher complexity today. So you can never predict everything in advance. And that's why you need to have small life cycles of delivery and often. So instead of treating your project like something that is perfectly secure and isolated, you should treat it as something that needs to be continuously updated and continuously tested. And this is agile, and this is Sec DevOps, DevSecOps, call it however you like. Yes, someone wanted to ask something.
Guys, don't be shy. We can read chat, and we can and you can just unmute and ask a question.
Hi guys. So I watched a video from Anton when he showed Sneak and I forget the second tool for CI to check your project for vulnerabilities. Anything else we can use to automate this, to do some checking?
Yeah, basically, you can use any tool you like. I was just showing those two tools during my, let's say, previous presentations on more or less the same topic, just because both of those tools, they are free, or at least they do have a free pricing tier. So that is why you can actually start using them. And as soon as you will have, as Aris was saying just a moment ago, as soon as you will get the first feedback, you will be able to assess, is it even actually worth trying or not? That's it. Because technically there are, of course, like companies who basically made all their business in a cybersecurity field. So that can be, I don't know, like a companies maybe like the McAfee, or a company like the Mimecast, or the company like, I don't know, basically, I can't remember only those two companies right now. Fortify, for example, that's, if not mistaken, the Fortify, that's probably not the name of the company, that's the name of the product. But anyway, so there are a lot of different vendors who can provide those different solutions. But the idea is that in one hand, you need to know that there are some tools that can help you to scan your libraries for well-known vulnerabilities. On the other hand, that may be a set of tools which can help you to scan your codes against some well-known patterns. For example, like exposing API which do not has any sanitation or something like that. The same thing that Aris was mentioned. I do believe that the key point here is that, of course, tools are important, but what is even more important is basically to apply your head to it, because the tools, they will not do the job. They will help you to actually address your attention to those most important parts of the DevSecOps conversation, But at the end of the day, that needs to be a human being who will create a plan, who will apply some other tools and fix those vulnerabilities.
I think it's valuable to add here that there's no silver bullet, there's no magic wand. So there's no perfect framework, perfect penetration testing engine. So things evolve, things change over time. So something you did your CI/CD, you think it's super secure, it's amazing, etc. Yes, maybe it's amazing today, but tomorrow, next year, or after a few months, and now other vulnerabilities, other cyber threats, more sophisticated and more advanced, are out. So you need always to stay up to date, and that's, and like Anton said, don't let a framework or a cloud native tool replace you. So security is first in your mentality and engineering and architecture. If you invest towards that direction, then you will also optimize the use of the frameworks and tools you do, and you will get the maximum benefit out of automated tools. But don't let these tools replacing you, because exactly there's no silver bullet, one framework for everything. So first of all, security is knowledge, strategy, and mentality, and then is tooling.
Great, guys. Another questions?
I have a question. What about part of time needed for investigate to security of all job time?
So you mean like if you want to start addressing security in your project, what will be the total investment? For example, like 1 day per week or something like that? Is that what you're asking for?
Yes. For example, monthly. If every month I have 1 day or 4 days, or maybe in 1% of all my team. What do you think better use, or maybe first step for this direct?
Yeah, I mean, like that's actually kind of a tricky question because it basically means that you already have a project. So you will basically start that, you will start to introduce security not on the first stage, but probably somewhere in the middle of the project. In that way, I do believe that you need to start even before. So first of all, before even start thinking about the security, I would recommend, at least from my side, to go through the assessment and first of all understand and define what security means in a way that, for example, what you are afraid of. Because in one hand, you can say, I want to address security in a way that the end user's data will not be exposed publicly. On the other hand, you may want to say, I want to address security in a way that my application will not be affected by denial of service attacks, and so on and so on and so on. So first of all, decide against which kind of attacks you want to protect yourselves. And after that, I will also recommend to assess what the potential impact will be. So for example, let's say that I am a hacker, and let's say that I was able to hack your application, and let's say that I was able to shut it down for an hour or a day or a week. So the question to you will be, what will be the amount of money that your company will lose because I shut down that application? And if I'm not mistaken, the rule of thumb should be something like invest around 10% of your potential losses into the security. Of course, you can always invest more, but that will be the minimal amount of efforts that I will recommend. So to give you like maybe a more detailed example, so let's say that your company will lose like $100,000 if the data will be compromised. So that means that you need to invest at least 10K into your security, and then you know the hourly rate basically of your team members, and that should give you a pretty much kind of rough estimate, or let's say kind of a ballpark estimate of what the efforts that needs to be to start addressing the security. Iris, do you want to kind of comment on that one as well?
Well, I find it a very good question, because everything starts from the decision. So first of all, you decide to invest more in security, and then that's a very valid point. So how much time do I need to invest? And as you said, Anton, you must first set your goals, because, for example, if your architecture is not using web application firewall, then there is no point for you to invest any time learning these aspects. Or maybe if your application doesn't need VPN, you don't need to invest time there. So first of all is realizing your goals, and like Anton said, investing the 10%, I find that very good percentage. So if you make that on permanent basis, or at least on a sufficient term, so it could be 10% for 1 year, for sure you can achieve amazing results. You will never reach the 100%, because exactly security is something continuously evolving. So don't expect that you will do that for 6 months and then you are done. So security needs to be part of your time investment, ideally permanently. I find the 10% very, very good. If that's not feasible, even lower than that can also bring some good results. So if you invest in security productively, even a few hours per week or 3 hours per week, which is very very few, or 2 hours per week, this is very small. But what matters is to do it. So even 2 productive hours per week you will still identify some security vulnerabilities. You will work on them, you will fix them. And security is also something that in the end is achieved consolidated. So imagine a huge wall created by hundreds of thousands of bricks. So there's no absolute security or absolute strategy. So you first understand the fundamentals, and if I could afford a few hours per month, very, very few, I would first go to a Wasp website to study the security basics, and then start investing time on the fundamentals that I find on OWASP that sound more relevant to my application. Just a simple example, every application has front-end code, all right? So if you have a website, first of all, and before anything else, you definitely need to spend some time securing your front end. Of course, it doesn't start from there. Everything, if you remember the first slide with the security layers, everything is data. So everything starts from your critical data. So in terms of priority, the starting point should always be your data. And some simple steps without, if you don't have special knowledge or very advanced knowledge, start keeping backups. Try automate your backups. That's a first step. That's not great security, but this is definitely a first step that at least can provide you availability of your data in case of a security incident. And if you invest in data backup and recovery, always make sure to have sufficient retention. Retention is how many days you can go backwards to pick up the image or the replica of the SQL to bring it back. Why I suggest you to have the longest retention period possible, or that the longest that your project or company can afford. Because in the case of a cryptologger, let's say cryptologger is a malware that is going and encrypting all your data in a way that is irreversible if you don't pay the fee to the criminal to give you the key that can unlock your data. So let's say that you have data layer, but you have an independent, you have other independent microservices. So the cryptologger could not hit these, could not attack the rest, but could just attack a data store with a server there. All right. So you might not understand if you don't have an advanced security architecture, or maybe some very decent already in place. That incident might happen, and you may discover it after some time. Let's say that it's a data store of some data not retrieved often, but still critical data. So what if you retrieve this data once per month, for example? So if a cryptologger goes there and destroys your data, and you don't have monitoring and logging in place and alerts in place, then you might discover that after 10 days that this has happened. And if your retention policy of your automated backup is no longer than 10 days, then you will simply lose that data. So to wrap this up, because exactly we exhausted all the time, everything starts from data. However, how to get started? Try to invest some amount of time every week. Go to a Wasp, check the basics, check the top 10, and start focusing on the parts that are more relevant to your application and your project. And of course, always start from the critical data.
Great. It was actually unexpected group, but quite a lot of information and great questions, great responses, and I hope to see you guys next time. I mean, you're always invited to speak at our group, and we're hoping for the part 2 soon. And probably I will wrap up this meeting, and thanks everyone who attended. A lot of strong people, a lot of great conversation, and thank you, Aris, thank you, Anton. It was awesome, and we hope to see you next time to provide deeper details and more information on this topic, because this is really hot stuff now.
Yeah, thanks for having us, guys.
Thank you, and see you next time.
Thank you, Stas, Anton, for hosting and organizing this event, and we can do more.
Yeah. Okay.
For sure. Yeah. Have a
See you
great
next
evening.
time, guys.
See you.
Bye.
Thanks, guys.
Thank you, guys. Bye.
Bye.